Hey guys, this is part 4 of the platformer tutorial. So in this video I will be doing the player class. So a quick recap of the last episode. We did the map object superclass, and this again is the base class for all objects in the game, players, enemies, etc. So I did leave one thing out though. Back in the check tile map collision function down here, when I'm doing the calculate corners for the x direction, I left out over here if dx is greater than 0 and if we hit a wall, stop, otherwise, else x temp plus equals dx. So that's that. And we do have an error over here, and that is animation. We don't have that class yet, so we'll make that now. Entity, add a new class in the entity package called animation. This is a very small. All this class will do is handle the sprite animation for us. So import java.auth.image.bufferedImage, and we're going to use buffered images, an array of buffered images to hold all the frames. So private buffered image array frames. We also need to keep track of the current frame, and we need some kind of timer between frames, and we need to know how long between each frame, so delay. And one more, a boolean called played once, that tells us whether or not the animation has played already, if it has looped. And this is useful for attacking animations where the animation of attack only needs to happen one time. So let's do the constructor quickly. Animation, this is just played once is false. And let me move this up. We need to have a way to set the frames. So public void set frames, and we're going to give it an array of buffered images. So this dot frames is equal to frames, and we're going to reset the current frame to 0 and set the start time and set played once to false. We also need to give it a delay. Set delay, that's just delay equals d. And we possibly might need set frame in case we ever want to manually set the frame number. I don't know how useful this will be, but for completion's sake, just have that there. We also need an update function, and this will handle the logic for determining whether or not to move to the next frame. If the delay is -1, then there is no animation, just return. Otherwise, we need to find out how long it's been since the last frame came up, and that's the current time minus the start time, divided by 1,000,000 to get it in milliseconds. And if that amount of time is greater than the delay, then we have to move on to the next frame and reset the timer. And we also have to make sure that we don't go past the amount of frames there are. If current frames is equal to frames.length, then we went out of bounds and we have to loop back to 0. Also, that means that the animation is played once. So that's that for update. Now we need getters. These are important. Here, public int get frame. This just gets the current frame number. And the important one here is buffered image get image. This will get the image that we need to draw. Return frames current frame. And we also need has played once, and this will return whether or not the animation has played one time or not. So that's that for animation. We're done with that. We're done with map object. Now we can finally move into the player class. So create a new class and entity called player. So again, this extends map object. so that it inherits all of this stuff from map object. There we go. Now we need to give it some player type variables. So player stuff can go over here. We need stuff like health, and this is a dragon, so he has a fire attack, so we need some kind of fire variable here. Let's go ahead and import some stuff first. Import tilemap.everything and import array list. We're going to be needing that. And import image.io.image.io for reading in the sprite sheets. And auth and auth.image.bufferedImage. Oh my god. .image.bufferedImage. There we go. Those are for drawing. Let me move this up. So that's that player stuff. We also need stuff like dead and flinching and a flinch timer. We also need the attacks, fireball, and this private boolean firing is for keyboard input. The fireball also has a cost, and it has a damage. And I'm not going to implement this in this video, so I'm going to comment it out, but we're going to need an array list of fireballs. There we go. We're going to create this fireball class later. We also have a scratch attack. So private boolean scratching. Again, this boolean is for keyboard input. We also have a scratch damage, how much damage it does, and how far it can reach, scratch range. And this is a dragon, so it has to have some kind of flying. Well, I didn't make it fly, I just made it glide. So private boolean gliding for that. Now, that's pretty much all the player has. Obviously, we can add on if we ever need the player to do more stuff. But that's pretty much it for now. Now we can do the animation stuff, animations. So, I'm going to use actually an array list of buffered image arrays to hold all of the sprite animations. So, array list of buffered image array. Call it sprites. Animation actions, these are enums that tell me, it's similar to the game state manager where we have these that determine which index, like 0 menu state is the first one, level 1 state is the second one. We're going to use these to determine the indices of the sprite animations. So private static final int, and the first one is idle, second one is walking, we have one for jumping, we need one for every animation that we have, falling, gliding, and fireball attack, and the scratch attack. So those are the 7 actions that we have. We also need to keep private final int, an array list called amount. Actually, we'll just call this num frames. And this is going to be the number of frames inside each of these animation actions. If we go over here to resources and check out the player sprites, you'll notice that the idle has 2 frames, walking has 8 frames. This is jumping 1 frame, falling 2 frames, etc. So this is we need to keep track of that. So 0 is idle, that's 2 frames, walking has 8 frames, jumping has 1 frame, falling 2 frames, gliding has 4 frames. Fireball has 2 frames, and scratching has 5 frames. So that's going to help us to read in the sprite sheet. We're pretty much done with all of that, so let's go ahead and do the constructor now. Public player tilemap tm. We're going to call the map object constructor with super. Again, the map object constructor, all that does is set the tile map and the tile size. So now that that's done, we need to set the width and height. Again, this is just for reading in the sprite sheet. The real width and height is c width and c height, and these are at 20. And now some of the physics variables: move speed, max speed. Make sure, I've been testing these values out and they've been working pretty good, so make sure you use these exact variables. If you change any of them, then it could break the gameplay because of stuff like jump start. It's equal to -4.8. If you make it any higher, or lower I mean, like -8.8, then this guy would be jumping like way too high and would reach areas that I probably didn't intend the player to reach. So these are the exact values for the game. 0.3. Facing right is true. Well, actually this is really not important, but I'll just keep that there. So the health also, I'm gonna start the player off with 5 health. I think that's pretty generous. And max fire is gonna be up to 2500, and the cost of a fireball is 200, and the damage it does is 5. And again, over here, up there, I commented out the array list of fireballs, and over here I'm going to comment out the creation of the fireball array, because we're not going to do that right now. So the scratch attack does 8 damage, and the scratch range is how far the scratch attack can reach in front of the player, and that's about 40 pixels. So that's that. Now we can actually load the sprites. Try, always in try catch. Here, print the stack trace. So let's try reading in the sprite sheet. First, let's get the sprite sheet. Buffered image sprite sheet is equal to image.io.read. And again, to read resources, you need to use getClass.getResource as stream, and the location is at /sprites/player/player_sprites.gif. I hope I spelled that right. Sprites player/sprites.gif. Okay, that looks right. So that's that. That's the entire sprite sheet. Now we have to extract each of the animation actions from it. Since we put everything into an array list, it should be easy. So for int I is equal to 0, I is less than 7, since we have 7 animation actions. So we have to create a new buffered image array. I'll just call that bi. New buffered image, and the size of this, again, I used the other array to determine how many frames in each animation there were up here, called num frames. So this is going to be num frames I, and now we have to actually read in the frames, individual sprites. So for int j is 0, j is less than num frames I, j++, and we're going to read this stuff in. Buffered image j is equal to sprite sheet dot get subimage, and I'm going to get rid of that. Get subimage. This is going to be at width first, so j times width, I times height, width, and height. Now we do have one problem though, and that is that I'm using width and height, which is 30 by 30, and that's the correct size for all of these. But you'll notice that the scratching frames don't have a width of 30, they have a width of 60. So I'm going to have to read in 60 over here for the last one. So I'm going to use an if here. If I does not equal to 6, which is the last one, then I'm going to read in regularly. Otherwise, I'm going to have to read in twice the width. So the same exact thing times 2 over here. So yeah, that should read in all the sprites. Now we have to actually add this buffered image array to the animations list. So bi, actually sprites.add bi. There we go. So that's finished. And yeah, so that's the entire constructor for the player. We can actually create a couple of getters before we get into the gameplay stuff. One for health, one for max health. This is mostly just for the HUD, so that you can see how much health you have. Max health, get fire, return fire, and get max fire, return max fire. What else? We need keyboard input, right? Public void set firing, and this is going to be firing is equal to true, and we need one for scratching. So public void set scratching. Scratching is equal to true. There we go. And we also, right, we need one for gliding. So public void set gliding. And this is going to be boolean b. Gliding is equal to b. The reason I have a boolean here is because we can stop gliding at any moment. But once we do an attack, we have to carry that attack out all the way through, so there's no point giving it a boolean. So now we can actually go into the main function here, update, public void update. This does all of the positioning stuff. So let's get into this. This is actually pretty complicated. The first thing we want to do is update position, and we're going to do that by creating a function called getNextPosition and calling checkTileMapCollision from the MapObject class, and last set the position to the temporary variables xtemp and ytemp. So that's that. We also need to do, I'm not going to do any of the attacking stuff for now. So I'm just going to do the movement, the basic movement stuff. So after we update the position, we should check the animations, set the animations. Here, the first one is if we're scratching, then if the current action does not equal scratching, then we're going to set that. Action equals scratching. And we're going to set animation.setFrames, sprites.get scratching. And animation.setDelay, this is 50. The width of the scratching is 60. So again, I use width for the sprites. So that's scratching. Otherwise, we need the fireball attack, else if firing. So this is pretty much the same exact thing. Action does not equal firing, or fireball, I mean. Then current action equals fireball, and set the animation frames, sprites.get fireball, and animation.set delay, and this is 100. Width is 30. Otherwise, what else? What other actions do we have? We have falling or jumping. Actually, let's start with let's start with falling. So if dy is greater than 0, then we have two ways to fall: the regular fall or the gliding fall. So we have to check. We'll check gliding first. If we're gliding, then we have to set the current action to gliding if it's not already, and set the animation frames, and that's Sprites.get gliding. Set the delay 100, the width is 30. So that's the gliding falling. But if we're doing the regular falling, then just if current action does not equal falling, current action does not equal or current action equals falling, set the animation frames, Sprites.get falling, and set the delay to 100, I guess is good. The width is 30 again. So that's all the falling animations. Now what about the jumping animations? If dy is less than 0, current action does not equal jumping, current action equals jumping, and set the frames, animation.set frames, Sprites.get jumping, Sprites.get jumping, animation.set delay. This is -1. Since there's only one jumping sprite, we don't need any animation with it. Set that to -1. The width is 30. So that's falling. We have jumping. What else do we need? We need moving left or right. Else if left or right, then we're doing the walking animation. Current action does not equal walking. Set that, and set the animation frames, Sprites.get walking. Set the delay. This is 40, 30 width, and the last thing is the idle frames. So else if current action does not equal idle, then set the current action to idle and set the animation frames, Sprites.get idle, set the delay 400, and the width is 30. So that's that. And last thing, all the way to the end, update the animation. And one more thing, set the direction that the player is facing. If current action does not equal scratching and current action does not equal fireball. We don't want the player moving when he's attacking, so we have to check for that. Then if right, then facing right is true. Otherwise, if left, then facing right is false. So that's that for updates. Let's go ahead and move into draw. This will draw the player, graphics 2D, G. Alright, we're going to call set map position. This should be the first thing that gets called in any map object, draw. Set map position, that's very important. So we're going to do some stuff here. We're going to draw the player. Oh, right, I have this flinching sort of mechanic where if you get hit, you're going to start blinking. So that will determine whether or not you get drawn. So if we're flinching, I'm going to find out how long has gone by since flinching, flinch timer, and get that in milliseconds here, divided by 1,000,000. And I'm going to do if elapse is less divided by 100, mod 2 is equal to 0, then return. We're not going to draw the player, and this will give it the appearance of blinking every 100 milliseconds. So if facing right, then we have to draw normally, g.drawImage. This is just animation.getImage. Animation.getImage at position x plus xmap minus width divided by 2, and the y is y plus ymap minus height divided by 2, null. Otherwise, if we're facing the other way, if we're facing left, then we have to draw the sprite flipped. So this is almost the same thing, but we're going to do animation.getImage, then the x position is going to be shifted up by width, so x plus xmap minus width divided by 2 plus width. The y stays the same, y plus ymap minus height divided by 2, and now we're going to flip it with negative width. Height is the same and null. So that's that for draw. I'm getting an error here. Flinch timer. I don't have a thing for flinch timer. Oh, I called it flinch time. Up here, it should be flinch timer. So that's that. We do have an error here. Get next position doesn't exist, so we're going to do that right now, and this will be the final function that we need for player for now. So we'll do that right now. Up here above updates, we can actually create it. So private void get next position, and this function is going to determine where the player should be, where the next position of the player is, by reading in the keyboard input. For example, if we're pressing left, then it has to find out the next position is somewhere off to the left. So stuff like that. Movement. If left, and we have to move minus speed. The vector has to go left minus speed, acceleration, and we cannot go past the max speed though, so we're going to cap it out at max speed like that. Else if we're going right, else if right, then just the opposite direction, dx plus equals move speed, and cap it at max speed like that. Otherwise, if we're not going left or right, then we have to stop. So if dx is greater than 0, then we have to subtract by the stop speed. And if dx is less than 0, then we've come to a full stop. Otherwise, if dx is greater or less than 0, then dx plus equals stop speed, pretty much the opposite direction. Dx is greater than 0, then we've come to a full stop. Dx equals 0. That's left and right movement. Now we can, first we have to check something. Here, in most games, platformer games, you can't attack while you're moving. So I'm going to implement that here, cannot attack while moving, unless you're in the air. I've noticed that you can still move while you're in the air, or while you're attacking in the air. So I'm going to set that here. If current action equals scratching, or current action equals fireball. Let me just move this down here. If current action equals scratching or current action equals fireball, and not jumping or falling, so cannot move, cannot attack, oh, this is wrong, cannot move while attacking except in air. So this is what this if statement is for. One more there. Then dx is equal to 0. We cannot move. So that's that. Now we have to do jumping stuff. If jumping and not falling, then dy is equal to jump start. and falling is true. And the falling stuff, if falling, then we actually have a couple of checks here. If dy is greater than 0 and we're gliding, then dy is fall speed times 10% of the fall speed actually. Otherwise we'll just fall at the regular speed. So gliding has you falling at 10% of the normal speed. So if dy is greater than 0, we're no longer jumping. Jumping is false. And if dy is less than 0 and we're not jumping, dy plus equals stop jump speed. This makes it so that the longer you hold the jump button, the higher you'll jump. So if dy is greater than max fall speed, we also have to cap it out at max fall speed, like that. And so that's pretty much it. So that was get next position. Let's go ahead and try testing this player class out. Go back to level 1 state, create a new player, private player. Again, inside init. Ooh, what's this? Can't see it. Right, we have to import. Import entity.everything. So in the init function, where we initialize all the variables, we're going to create a new player, pass it in the tile map. We're going to do player.update, update player here. So and in draw, we draw the background, draw the tile map, and now we're going to draw player, player.drawG. Let's see if this works. Hopefully it works. Oh, we have errors somewhere. Player doesn't have an update function. Oh, I spelled it wrong. Update. There we go. So let's see if it works. We're getting some errors here. Let me find out what these are. Null pointer exception. Sprites. Of course, I didn't create the sprites array. All the way back in the player constructor, when we load these sprites, we're going to do sprites is equal to new array list buffered image array. So that's that. Hopefully that's the only error we have. No, still have errors. Over here in update we have another null pointer exception, animation.update. So animation doesn't exist. I'm pretty sure I set it somewhere. Anyway, right after loading the sprites, we can just set that animation is equal to new animation. Again, this is in the player class constructor. Right after we load the sprites, after the try catch, create a new animation. Hopefully that's it. Oh my god, okay, there's some more stuff here. Null pointer exception, frames is null. Oh, okay, right. So, if we go to player, we'll just manually set the animation to something. What do you call it? We're gonna do current action is equal to idle, and animation.setFrames to sprites.get idle, and set the delay to 400, I think it was. Hopefully that's the last error. Okay, so we do have a thing here. The problem is the player is all the way up here on top left corner at position 0, 0. So that's wrong. Let's go ahead and set the player position somewhere else. Set position to, let's say, 100, 100. Ooh, player dot set position 100, 100. Let's check this out now, and there's our player. Can't move right now because there's no keyboard input, so let's go ahead and do that here. Down here in level 1 state.java, we have these two functions, key pressed and key released, and all we're going to do is set the player stuff So if k equals key event.vk left, then we're pressing the left button. Then oh, key event doesn't exist. All the way back at the top, we can import that. Import java.auth.event.key event. Okay. So if k is equal to key event.vk left, then player.set left true. We need one for right. Well, we need one for all the directions. So player.set right true. We need one for up and down. Up and down. VK down. Player.set down true. What else do we need? We need one for jumping. I always use W for jumping for some reason. It just feels it feels right. I guess you can use whatever, but obviously you can use whatever key you want. But I find that WERF just fits nicely, I guess. So what else do we need? Event.vke. This is the gliding button. Player.set gliding true. And the attacking buttons, these are VKR is the scratching attack. Set scratching. And the fireball attack is F. Player.set firing. So over here in key released, I'm going to copy and paste all of these with the true in them. And in there, except I'm going to change all of these to false. Because we've released the key, we are no longer setting these to true. So there we go. Let's test it out now. There we go. Start. And we can move around. Cool. Jumping, gliding, scratching. Looks weird. Oh, it's like stuck. Well, I did say that I didn't do any of the scratching animations or the attacking stuff in the player yet. I said I would only do the basic movement stuff. So that's here. That's what we did here. Jumping, gliding works. Attacking, gliding, jumping. Alright. So the tile map is not moving. We could actually set that here as the last thing for the video. Over here in player.update, we're going to do tilemap.setPosition. We're going to set it at position depending on the player position. Game panel.width divided by 2 minus player.getX. This will keep the camera centered on the player. Game panel.height divided by 2 minus player.gety. So we'll check that out now. And the tile map is not moving for some reason. I'm pretty sure I'm drawing all of this correctly. Okay, so I figured out what the problem was. After fumbling around for a little bit, I figured out that I didn't set, over here in fixed bounds, I didn't set xmin, ymin, xmax, or ymax at all. So that's pretty sad. So back here, when we load the map in tilemap.java, we have to actually set this stuff. Over here, xmin is game panel.width minus width, and xmax is 0, and ymin is game panel.height minus height, and ymax is 0. Hopefully that should fix it. What else did I do? Set the tween to 1, make sure the tween is 1. And there we go. Okay, so now the camera follows the player around. So you can go ahead and explore the level if you want. So that concludes this video, and I will see you in the next one.